Welcome to episode 317 of the Red Dirt Agronomy Podcast. I am Dave Deacon, and we got a really fun episode for you. Today on the Red Dirt Agronomy Podcast, we're talking with Oklahoma State University animal scientist, Dr. Andrew Foote. But before we do that, go ahead and bump that subscribe button where you get your podcast. And remember, you can find all of the information we talk about on this episode and past episodes on our website, reddirtagronomy.com. As always, we start with a quick trip around the table for an introduction to the dream team of dirt and everything that grows from it. Let's start with Oklahoma State University Extension Precision Nutrient Management Specialist.
Never once has somebody answered this in the way that you've asked it, so we'll see if Andrew can pull this off.
Dr. Brian Arnell. And across from him is Oklahoma State University Extension Cropping System Specialist.
Well, yeah, I mean that you remove the curtain and then you dig, you know, like a small rodent or animal or something.
Dr. Josh Lofton. So without further ado, let's jump into our conversation with Dr. Andrew Foote, recorded on October 11th, 2024, nestled away in a huddle room in the new Ag Hall on the Oklahoma State University campus. You are listening to the Red Dirt Agronomy Podcast. So, Brian, let's just kick things off, introduce our guest this week.
All right, today we have on Dr. Andrew Foote. Andrew has been with OSU a couple of years now, and I forget, what year did you come in, Andrew?
2018.
2018, right at that wonderful time. Yeah, more than a couple. less than a dozen, more than a couple. Thanks, Josh. Ruminant nutrition physiologist. Haven't got to work with Andrew as much as we want. We kind of interacted because of children activities, but we were looking for somebody and everything that's going on as far as some of the projects Josh and Andrew have jointly, and then other things I thought Andrew would be a really good ad.
Very cool. Dr. Foote, go ahead and kind of tell us what you do with OSU.
Sure. So, like Brian said, I've been here 6 years, and my appointment is mostly research, do a little bit of teaching. So my research focus is kind of broadly in sustainability of the beef production industry. I focus more on feed efficiency and kind of nutrient utilization, trying to find what makes animals more efficient than other animals, and with the idea that, you know, if we can identify some of these mechanisms, maybe eventually we could manipulate them for the producer's benefit, right, for the environment's benefit, and that kind of approach. And we've expanded kind of what we're doing over the last few years. So.
With what you're looking at now, does it impact the cow-calf operator more, or more of the feedlot and the confinement side, or where along the supply chain is a lot of what you're working in at?
Right. So most of my work has been on the feedlot side, the growing animal. We've done a little bit on grazing animals, but again, more focused on the growing stocker side potentially. I think, you know, Dr. Lawman has done a great job with his cow efficiency stuff. So, and I certainly collaborate with him, but my interest has been more in the growing animal side, whether it's grazing or feedlot.
Is there value proposition later, do you think, if a cow-calf producer could be producing stockers that are of a known feed efficiency? Is there some value add in that?
Yeah, I think absolutely. And even past the stocker to the feedlot, some of the stuff we've been doing trying to identify efficient animals has sort of gotten the attention of some feedlot consultants. And they've kind of approached it of, how do we use this to develop some sort of test where we can identify our value animals when they come into the feedlot, or when we're trying to buy them, or, you know, potentially a cow-calf guy could market his as having certain traits that could make them more profitable potentially for the feedlot or the stocker.
Years ago, and you mentioned Dr. Dave Lawman, years ago, when working on the TV show, I remember going out to the North Range and Dave going, okay, this is a highly efficient cow. And I looked at it. I looked at the one right beside it. I could not visually tell the difference between the two, but he explained how they measured it with the RFID tags at the time. I don't know if that's still how they do it, but they were able to measure input and output of the animal. Kind of walk us through what are you looking for whenever you're researching those highly efficient animals?
Sure. So very similar. The hard part of doing this is measuring the input and the feed intake of the animal. That's where a lot of the expense and the time and effort and kind of has limited the industry improvement overall, because we can do it in research, okay. Doing it in real world situations is much more challenging. So yeah, in kind of a broad sense, it would be that measuring inputs, measuring output. Our main output would be body weight. Just how much are they growing over a certain amount of time. That also is a little problematic because cattle, similar to anything else, you think about kids growing, what they're growing isn't always the same. Right. So, if a animal is putting on more muscle versus more fat, we don't really pick that up if we're just measuring body weight.
Right.
And that can drive some of the efficiencies as well. So, in a perfect situation, we'd get a little bit deeper into something besides just body weight. So some of what we've tried to do past this is get more specific into specific nutrient utilization. And my interests have kind of turned into the protein efficiency or nitrogen efficiency, as we'll usually talk about it in ruminants. So trying to find ways to improve that, because it can have a big economic impact as well as an environmental concern.
What different ways internally, if we look at the animal system, the ruminant system, can the nitrogen efficiencies change? What mechanics of that animal's changing, whether it can be efficient or not?
Yeah, so I think some animals are probably more efficient in how their rumen, the microbes in the rumen, use the protein and convert it to something usable, versus getting excreted as a waste product. I think there's certainly some animals that what we'd call post-absorptive metabolism can be more efficient. So once they absorb the amino acids, they're better at converting that into muscle meat than some other animals. So a lot of what I've focused on is more in the GI tract and how the rumen is using that and converting it, and that's kind of where my interests have lied so far. But
I want to go back to something you said a little bit ago about like the size of your research and the size of scale, and that's always interested me. We move from like row crop production to forage production. We have to increase scale, and then when we get into grazing, we increase scale even further. What does your scale usually look like from a research perspective? Whenever we talk about normal things like, us, it's fairly easy plots, and those kind of things. But,
yeah.
Sorry, random bypassers here in the middle of the podcast. Yeah, we have
become part of the tour.
we have, right? So sorry for the listeners, but if this is recorded, so the dean walks by, we're like, oh crap!
Yeah.
And then all of the alumni winners. So that was the alumni of the year winner. Schroeder was there. Yeah. So
I saw Dr. Ron Elliott.
And then Dr. Elliott.
Yeah,
exactly right.
I'm sorry, you were talking about cattle.
So the scale of the research, since a lot of what I do lends to the more basic research, we're a lot of times doing pretty small scale but very intensive type work. So a lot of times we're using 8 animals or something, and scaling up. Part of what we do is also looking at variation in animals, so you need a lot more to look at variation. So for me, a big study would be 60 to 100 animals. But a lot of what I like to do is to dive deep and use fewer animals. And we do a lot of like rumen fistulations to be able to sample the rumen and see what's going in, what's going on.
So say what that is. I know what it is, but I think I know what it is.
Yeah. So that a fistulation or a cannulation is where we would surgically create an opening into the rumen.
That's what I was hoping it was. Yeah.
That's how Dave grins. Like,
Hoping it was?
Yeah.
Okay. Dude, you could, yes, go ahead. Sorry.
Yeah. So some people describe it as a window into the rumen. So it kind of allows us to research a little more in depth what's going on inside.
Well, so I guess going on that to plug into that a little bit. So instead of measuring ins and outs, you guys get to look behind the screen a little bit using that. Yeah, you get to pull back the curtain a little bit.
Right.
So, like, what extra things do you get to learn from a nutritional and an efficiency standpoint that you wouldn't learn from just an ins and outs perspective?
Right. So we know in some certain nutrients that what's complicated about a ruminant is they have the rumen, and then from there it goes into the small intestine. And if we shift where nutrients are digested, that can change the efficiency of what the animal gets out of the feed stuff. So by taking that deeper dive and opening the rumen to look at that, we can start looking at, well, if we shift it from the rumen to the small intestine, is there an efficiency to that, or vice versa, where if you didn't have that, you would just know what's coming out the back end. Mm-hmm. And so then it doesn't give us the complete picture of what's truly going on throughout the GI tract, if that makes sense.
Oh, yeah. It's like you and phosphorus, the black box of what's actually happening in the soil. And, you just know what happens and then what happens at the end. Huh?
Some people don't care. We just want to know what comes out the back end, and some people care.
Exactly.
This is a conversation we have all the time. We talk about plants, and I'm like, give me the yield. Just like, well, what happens? Like, I don't give a rat's ass. Just tell me if it yields. He's like, well, why? I'm like, that's a researcher. No.
No, it's somebody wanting to know a little bit more. Hold on, but
if I had more time, go ahead.
So then when you go, so we talked about how you'd want smaller amount of animals and being able to dig down into each animal a little bit more.
Well, there's a door on the side now, so I can dig down a little further.
Physically,
well, I mean that you remove the curtain and then you dig, like a small rodent or animal or something.
Air quotes, dig a little deeper. Okay, I got you now.
But so then size of scale, so making it important, so handing it off to your extension counterparts, and how do you make that important for a herdsman? I guess is where is that tripping point? Is that a pretty easy, smooth transition to go herd level, or does that get a little bit tricky when we talk about how much variation each animal potentially has then?
Right. That's, in a lot of ways, that's the $1 million question of, can you take the basic stuff and turn it into something applicable? And I'm trying to develop that skill of telling that story to make people care a little bit more. Some things it's much more applicable. Some lines of research are, several steps away from an application. But, a lot of this we can try and tie some economics into it. When we talk about protein, some of what we've been doing is looking at different sources of protein that have a cost difference. But, there might be situations where paying a little more for the protein could pay off a little better.
Talking DDGs versus supplement. Is that what you're getting into on those conversations?
Yeah. So one of the projects we were asking the question of, thinking about cow-calf or stocker people that have second jobs. And if they aren't able to feed their cattle every day, should they use a different protein source versus ones that go feed every day? And this we tied it in because protein nutrition is going to lead to nitrogen emissions, which can have a number of environmental problems, including water quality. Assuming it actually rains or something, you can have some water quality issues, as well as ammonia emissions that have human health implications, and nitrous oxide, which is a huge greenhouse gas problem. So that's where we've kind of gone, and then, asking that question of, if you're not going to feed every day, twice, 3 times a week, if you pay for this more expensive protein, they use it better, so less of it's getting excreted and causing environmental impacts.
Josh, DDGs, dried distiller grains. Yep. And so, but to Andrew, so you're saying there's like a slow release nitrogen, slow release protein. What does that look like? I'm trying to think.
Sure.
Chemical structure is like a long chain protein with a lot of things added to it, or what?
Right.
What would be a slower?
So a quicker digesting protein would be something like soybean meal.
Okay.
And what makes it quicker digesting is that it is water soluble. That protein is more water soluble. So whatever the amino acid or secondary structures make it dissolve in water better. So when it does that, it goes into the rumen and can be dissolved and digested there. Where something like corn gluten feed or DDGs a little bit, distillers grains a little bit, they are not as water soluble. So corn proteins are not very water soluble. So they don't get digested in the rumen. They can go to the small intestine and be digested and potentially be beneficial for the animal. It's a balance because we need protein in the rumen. The microbes need the protein so that they can digest the fiber. And so it's kind of trying to find a balance of you want enough but not too much.
It sounds like to me that you're taking the approach of there is this animal, it's just your standard animal, and you're fine tuning the feed that's going into it rather than this animal is bred to become this super efficient, put the food in, boom, goes directly to weight type thing.
Yeah, so I would say we're doing both.
Right.
There's certainly a line of research trying to figure out, can we identify animals that are better at it, but also, that takes long time to identify that and then utilize that information. And in the short term, we should figure out how we can just manage them better to have those positive impacts.
That's really interesting.
You weren't extension, and I asked you an extension question. So you're also not an economist, but I'm going to ask you that.
That's why he didn't say it depends.
Yeah, that's it. He doesn't know that phrase yet. That's part of our training 101. How important is this on the size of scale of herd? Like, does this change importance depending on herd size? Like my in-laws, they got 20 head. They're trying to make a little money on the side, so they don't feed every day. They're more sporadic feeders versus a 1,000, 2,000 head operation that maybe is a little more meticulous with their feed and their feed rations.
Yeah, that's a good question, and it depends.
There he is. That's it.
Welcome to the world of extension.
But yeah, and that's where it gets complicated. Is the scale can drive that, and part of the cost of feeding is the fuel to get there and to haul the stuff, and if they're in your backyard, it's a lot simpler and versus having to drive across the county to go feed or something. So I would like to think that my research is applicable across the scope, but we can look at the statistics and see what the average herd size is and then kind of do our economic modeling there. I'm getting out of my place there.
We do every day. It's okay.
That's a place
That's
we live.
what we play around
in our place.
Yeah. So I'm going to maybe go off rail a little bit. No, this is this is the next one.
Supposed to have cheat sheets. I
was trying to take notes though, and you don't have a pen for me. So, Foote, we look at a lot of stuff we've talked about maybe genetic differences. The traits along the lines of that. How much does the environment which the animal is in influence its ability to metabolize and convert nitrogen into protein?
Massive, probably.
Great. G by E.
Yeah, and that's certainly an active area of research. I haven't done a ton of that, but the environment's going to drive everything.
Okay.
When you think about an animal that's heat stressed and what they eat, how often they eat, and that all of that's going to drive efficiency. And yeah, certain animals are genetically predisposed to do better in certain climates.
So I'm not surprised by stresses influencing that, but can a few degrees shift or a little shift in humidity? I mean, how sensitive is the E proponent, do you think, in some of the...
I don't know if we know that.
Okay.
But and I think, there's some interesting stuff even just beyond temperature. And some of it is really even wind speed and humidity that can change some of the way the animal can dissipate heat. But there's also kind of way outside of my area, but we're starting to see more and more even with altitude and where those animals are adapted to altitude. So like people at Colorado State have been very familiar with this for a while because they've seen cattle that have multiple generations from lower altitudes. They take those up in the mountains and they fall apart.
Yeah. Now, I've heard about that. A lot of Florida and Tennessee cattle going up into the Colorado and the Montanas, and they just can't. And the way they react when you bring them from altitude into the lower regions, I've always heard, at least the farmers, the guys that are buying and selling cattle are always talking about the difference of high altitude and low altitude cattle.
How long has this been a focus for researchers? Because, I mean, is this relatively new, 50 years? Has this dated back to like the 1600s? They've been...
The environmental component?
Well, just the research into efficiency.
Yeah, that's a good question. I think we've, as far back as we can kind of trace production agriculture in the U.S., I think there's always been a little push to efficiency. And most of the time it's kind of driven by labor availability, I would think. It's kind of funny going back to, as far as I've looked, would be like post-Civil War, where people started really kind of trying to get more efficient, and that's kind of when the term factory farm came in.
Yeah.
And it's interesting. There's some literature out there that, in the late 1800s, it was actually kind of a good term because they were trying to show, hey, we're trying to be efficient in producing your food, and it's gotten a bad stigma now. So there's always been a push for efficiency. Right. The more look at feed efficiency, I would say, has really only been in the last probably 30 years. And a lot of that has been driven by commodity prices. A lot of times beef producers aren't going to care too much about feed efficiency when corn's cheap.
Yeah.
And so we can kind of look at, if you plot corn prices over time, the amount of there's a strong correlation with feed efficiency funding, research, and corn prices.
How do you take your findings from a large scale, approach to your research, more of a feedlot approach? How do you translate that to the mom and pop that, like Josh said, have 20 cattle at the most? How do you get them excited about putting the investment into higher efficiency cattle?
That's a tough one.
Yeah.
Because I think efficiency means something different to everybody.
That's true.
It's kind of like sustainability.
Yeah.
It means something different to everybody. So I think the thing that hopefully would motivate them is the economics of it. I think the beef industry also has a sector that the economics are very different in our seed stock industry, where I often make the example of, these producers that are trying to make $1 million bulls or $2 million bulls or whatever we're up to now.
Yeah.
They probably don't care as much that feeding those out are going to cost 10% more or less. So the beef industry is tough to kind of broadly motivate people because their motivations are so different.
Right.
I would say.
I know you mentioned earlier in our kind of prep on this about the potential, if it rains, joint project with Josh. Can you guys go and talk about what you guys are looking at?
Yeah, this is a project I'm pretty excited about, and it's kind of it's a very interdisciplinary multi-year project, and it sort of started with our focus on nitrogen efficiency, and then we've kind of scaled it up to a systems look. And the specific system would be grazing wheat pasture in the southern Great Plains. And I'm going to step on y'all's turf a little bit, but growing wheat requires a lot of nitrogen fertilization. And then in the systems where we're grazing only or maybe dual purpose wheat, there's a large amount of the year where it sits fallow, and we kind of started asking the questions of, well, could we do something over those summer months to have some environmental impacts or some soil impacts, forage production? Could we do something with that land for the producers to get some economic benefit out of it? So the idea was kind of to look at using summer cover crops, specifically that contain legumes, to hopefully fix a little soil nitrogen, and also provide a high quality forage that could either be grazed or harvested to provide some economic output for the producer, as well as hopefully some soil nitrogen that could be beneficial for the next growing cycle. And again, that gets complicated into soil dynamics and forage production economics. And then, we've got the animals that are out there doing their thing, and that may be good or bad. So it's going to be an interesting project, I think. And
kind of a side spur that I've always been interested in is, we've talked a lot about cover crops, especially with our grain producers in the last several years, and a lot of them are heavy. If we can't graze it decreases in our value quite a bit, and it's hard to bring them into a system if they're just going to sit out there and we can't use them as a forage. But some true conservationists would say that that's a forage, then that's not a cover crop. And so there's a lot that. And the interesting thing is that the folks in the middle, whenever you ask them, like, what impact does grazing have on soil health, I think most people would say that they're either net neutral or positive. But the true blue, staying on the rooftop conservationists are going to say it's a negative impact, and I want to have some data to prove that. And I think it's an area, especially we've seen areas to where it's we've hated it, we've altered that plant, we're trying to make assumptions based on that. But there aren't a whole lot of studies that actually have the animals out there with the excretions adding to that, plus the hoof traffic to do a compaction, so there's a lot of interweaving things
which is why we need to publish Bronx large scale stuff at Noble, where we did that for 7 years.
There we go. See, you have that data and you're just hiding it, and I want it.
Weren't you on that committee?
No, I was not. Well, I was not invited.
Well,
to be honest,
we'll talk. We'll just say that was Noble's fault, not ours.
But
the funny thing was that I made, because we had both large scale and small scale. You remember Bronk on that plots and winter wheat with the summer. He started out, Noble wanted it called it summer cover, and we hated it every time, right? And so in Ardmore, large scale, it was cattle on it. So we have gain, all that stuff. That actually might be published in the next month or two. But we have the cattle gain, and then the small plot was hayed, and I made him remove the word cover from his dissertation, because I hold that if I hay it or I graze it, it is not a cover, it is a forage.
Yeah, and so there's a lot of back and forth on that. Talking to local NRCS, I think we're on the same foot, that as long as you appropriately graze it, to where we're not letting the cattle lick the ground clean, and we're being timid on our stalking rates and our grazing length and our recovery period, that it still can be considered a cover crop, because a lot of the functional benefits of that, the potential nitrogen recovery, the cover, the all that, in addition to potentially increasing the value of the forage that's out there, because we're adding unique crops that have their own nutrient profiles, is an added benefit.
And now we're going to argue, because I would say the same thing for winter wheat. Don't graze winter wheat to the freaking ground, then it's a cover. What's the difference of maintaining a proper grazing height on wheat and leaving 6 inches of wheat out there? Now, a grazed winter wheat crop by that standard would be a cover crop.
Well, I mean, if you look at it from a dynamic nature, winter wheat is a cover crop for 9 months of the year. I mean, because it functions as one.
So then we're doing a cover.
Sure.
There we go.
There we go. Double cover.
double cover.
But I think there's some intentionality differences in that, and when we're talking about wheat, if we graze it, I've seen wheat pasture in this state. Most of the time, it does not function as a true cover. If we're saying that it is a cover, adding the legumes is a functional change because we're wanting to cycle that nitrogen into that system to kind of add that benefit to the system. If we were to graze the wheat a little lighter and maintain a little more of that canopy coverage, we probably could argue that is a cover and a forage at the same time. I mean, most of our winter cover in the state is a small grain. So, I mean, it's no different. Intentionality matters, though.
I'd agree.
So, as the only non-PhD in the room here, my impression was if you have the intent of improving the soil quality, that, again, not fully knowing, I would have taken it as that's a cover crop, not necessarily a forage, because you are intending to improve the soil quality.
But I would say I would intend to improve the soil quality on no-till corn and leaving the stalks.
Yeah, but I think we've moved away.
That's where the argument would be for me.
Yeah, I think we've moved away from this concept of improving the soil quality. That's an old phrase that, like, when we didn't have the knowledge or the technology to tease that soil quality concept apart, I think we could make that concept.
Right.
But now there's so much more to it. Well, what quality? Organic matter?
Reintroducing the nitrogen into the ground.
Well, okay. Then I mean,
because, again, non-PhD here, you have your wheat, you have your rye. That doesn't necessarily bring the carbon back to the nutrients and all of that too.
But if I graze a soybean, I don't really get much. If I'm pulling the majority of that biomass off legume, I'm not getting that much because the rhizobia that's making the nitrogen is sending it to the leaf tissue, and the leaf tissue is then ingested or removed in hay.
Yeah.
And so the contribution of legume that all above ground biomass has been removed by harvest is much less than a legume that is completely left within the system because that leaf tissue has so much of the nitrogen component.
Okay. Well, and I think the interesting thing with this project that'll be very interesting because you're right. I mean, most of that nitrogen during that time that it would be there is not in the roots. It's being distributed to that leaf tissue. But then inherently, if the cattle are ingesting it and excreting that out, then efficiency becomes a big important thing because if our excretions increase nitrogen, we might not get them as much return as if we were to leave it lay. But we're getting more return than if it wasn't there, potentially. Yeah, and I think that's kind of what we're trying to see is if, okay, we're adding a legume and we're going to graze it. We're going to graze it. It doesn't matter what you argue if that's a cover crop or forage. We're going to graze it.
I only argue with you.
Now it's how does that impact the nitrogen on a grazed system, the next small grain?
Well, and that's one area I'm kind of interested in is the route of excretion from that animal because I don't have great data on this, but I've got some inklings that depending how that protein or nitrogen is excreted by the animal, if it's in the feces, it's going to get reincorporated back into the system different than if it's in the urine.
So we need RFID tags that also have bolus to pull through, and I need to get a drone that can go both urine patch and manure patch to see the redistribution. Because I think there's been a little bit of research that shows the redistribution can be focused on water points, other points.
Well, I think the fun thing on this is if we ever get the wheat to start growing again, and I mean it'll grow, and when we integrate those summer cover crops, we're going to be able to paddock these pastures off. And the very interesting thing, because I'd never been out to the wheat pasture unit before we.
Which one?
Dr.
Reuter's on range and
it's on the range
51.
So
all right,
it's right behind Sparks.
Yeah.
And so I'd never been out there, but then we went and took soil samples. And so when we paddock those off, so we're interseeding those legume cover crops into already a system that has very dynamic vegetation because it's got hilltops, it's got lowlands. So we have some area with very positive crabgrass pressure, that are going to be a grazing source, some that's going to have a lot more ryegrass pressure and all through. So then we're going to be able to see, and one of my students, Tori's on this project, she's going to be able to, we're going to put enclosures that we're going to be able to see like plant dynamic differences between these grazed and ungrazed systems and how it impacts these natural systems. And then we can go back and look at the nitrogen that Dr. Mary Fultz is going to look at the gas emissions and how that is impacted by those native populations and those dynamics that are already there. I think there's going to be more data than we can probably conceptualize in this
honestly,
short term.
We need to run a high resolution drone at 3 points in the season to get that distribution of species mix. As I pull that with my PHX, that would really show some of that even outside of the paddock and all that stuff.
So what kind of sensors would?
We have RGB, NDVI, and Red Edge. So I've got multiple. We don't need hyperspec, but just with what you were doing, if I was doing that, I would just use RGB visible image and draw circles around the areas that have importance.
Dave's perplexed over there.
No. I'm just thinking of flight paths. Can you do that over there by Sparks?
Yes. You notify the tower at low altitude, and I'm good to go.
So this
100 feet.
I'd actually be flying his at 50 to 60.
Okay.
So it's not actually Sparks. It's over by
purebred beef.
Purebred beef.
Okay.
So it's a little further away.
Sorry.
Sparks is a no-fly zone.
That's what I was thinking.
Well, I mean, we get permissions from tower to fly the long terms on their agronomy farm.
Okay. Yeah, the flight is 100 feet.
Flight
there.
deck is about 100. Yeah.
Yeah.
But so with a high resolution, I'd want my camera. I'd be wanting to fly at 100 anyways to get that sub-centimeter resolution per pixel.
Okay, sorry. I'm a 107 pilot, and so I'm like, that's restricted area. Gotcha. Carry on.
I hope that's added in. Please keep that in there.
I'll leave it in for you, Josh. I'll leave it in there.
But like I said, I think we're going to garner so much information that in this. You say it's long term, and it is, several years, but I think we're only going to be able to scratch the surface and what
more questions than answers.
Yeah, I think this is a nice start of a line of questions that can probably be asked on this.
Yeah, and it's fairly specific into that system is a no-till system. It's a graze out. There's no grain, so. Long term, I'd love to expand it into dual purpose or into tillage or something. I think, using those legumes I guess the term would be if you tilled that in, it would be green manure. And I think the gas emission data I've seen on that, it's actually not good.
Yeah.
The emissions from the green manure seem not beneficial. So I don't know. There's a lot of. This will tell us a lot, but it's just going to cause more questions than answers, probably.
As a researcher, it's a lot safer to do work that creates more questions than actually answer something, because that means our job's done.
That's true. Job security.
Then you got to think of something else.
That's even harder.
Well, what other questions do you have? I don't know. Let's come up with something. We switch to extension work. Okay, go out and tell
me. Hey. Easy there.
Should note that this project does have a large extension component too. So we have some interest in producers that are using these forages or cover crops, whatever you want to call them. But we've got some capacity in there. We want to talk to people that are doing that, or maybe convert people into doing that. But then we have some capacity to also provide some forage analysis. If they're doing it, we can help them out with that.
So are you only looking at like an interseeded legume, or are you also looking at a crabgrass system or a cereal system in the summer?
So the comparison is the cover crop mix, which will have some cowpea legumes in it, and among other things, and then contrasting that to just what I would describe as just natural growth. In those pastures, it's going to be predominantly crabgrass.
So we usually ask the folks that go extension to teaching, because those are both educational fields. But so how is your research as you've kind of developed it because you taught since the first year you got here, correct?
Pretty much. Yeah.
So how is your research and what you've gained and garnered through this time kind of influenced your teaching and potentially vice versa?
I wish I'd have had that question in advance.
No.
We don't do that.
That's a good thing. I think I've gotten better about simplifying questions and explanations. When you teach, you have to think more process-wise and how am I going to explain this, and step back a few levels compared to in my previous life. I was just a research scientist, so we were always thinking very high level. And then coming in and even teaching grad students, you got to take it back a few notches.
Then sometimes, as a 100% researcher, you kind of get lost in the trees, because you get so buried down into that one specific question. So has that helped you think, in your research by looking at the basics of your field and having to take that step back and look at the processes as a whole and saying, okay, I was really deep into this, but if I would have taken like 3 steps back, looked at the process, the answer's right there.
Yeah, I think so. And probably on the nitrogen stuff, especially because it was, before I got here, it was never anything I spent much time thinking about. And then through teaching classes and talking about the physiology and the metabolism and stuff, it kind of sparked questions in my head and has sort of spawned that whole area of research to go from there. So yeah, I should have said that in the first place.
Now Dave will just edit, so he'll take
right.
that blurb, put it up first, and follow through, and it'll just seem like a seamless, beautiful answer.
Well, thank you so much, Dr. Andrew Foote, for going on with us this week. It's been a lot of fun, and we learned a lot. Thanks for going on.
Yeah, thank you.
Thank you for listening in on this conversation of the Red Dirt Agronomy Podcast. And if you'd like to join the next conversation, send us an email, podcast@reddirtagronomy.com, or send us a tweet. Our handle is reddirtag. And of course, we'd like to thank Dr. Andrew Foote for joining us on this episode of the podcast. And if you get a chance, visit our website, reddirtagronomy.com, to find out more information about our guests and any of the resources that we discussed on this or any previous podcast. For Dr. Josh Lofton and Dr. Brian Arnell, I am Dave Deacon, and we all want to thank you for listening. The proceeding is a copyrighted recording of Agnow Media, LLC 2024. And yes, all rights are reserved.